These two things I haven't did. Okay. So today's discussion will going to be about the machine dependent loader features. We have seen two methods can be used for specifying the reallocation. The reallocation concept itself is the only one machine dependent loader feature. One is reallocation, one is two different varieties of reallocation. So two methods can be used. One is by using the modification bit, which we were doing starting from our assemblers only. So the modification bit can only be applied for format 4 instructions or the direct addressing. I have made it very clear. So wherever there is 20 bits of address is there in SIC XE machine, there we can use modification bits. Here we are going to specify an additional record called as modification record, wherein we are going to specify the starting address, that is the address of your operand which need to be modified. How many half bytes, that is 20 bits when it is represented in half bytes, we are going to get 5, 5 4s are 20. So 5 half bits need to be modified with what? What it has to be modified? That is nothing but whatever is there that should be added with the address specified next or subtracted with the address specified next. Here in our example, we are specifying that we should add the copy, address of copy. That means whatever is the load address that need to be added up with that. Fine. So this is one way of doing it. So the start address to be loaded with 5 half bytes, that is 20 bits starting from 00007 as the address. Fine. This method is efficient and specifically telling if it is SIC XE program. The reason remains to be is in SIC XE program we have different varieties of addressing modes or different formats of instruction. Also we have a instruction which is 1 byte which doesn't have operands. We do have for 2 operand, that is a format 2, which is a register to register operations. So 8 bits is used to specify 2 registers, and format 3 instruction, which is either is a PC relative or either is a base relative or either is an immediate addressing or either is an indirect addressing. In any 4 of these cases, we will be specifying the offset. But if it is immediate, we will be specifying the value of the operand itself. But if it is what you call PC relative or base relative or indirect, we will be specifying the offset or the displacement. The displacement will be computed either related to PC or either related to base address, whatever it is. But it is a distance, either a positive or a negative distance relevant to PC or relevant to base register contents. So that anyway the distance remains the same wherever is the program is being loaded. So no effect happens with concern with what we call it as the format 3 instructions. So no need of reallocation. But format 4 instruction is a direct addressing. So for that reason we used modification address for format 4 instruction, clearly specifying from which byte how many bytes need to be reallocated, means to say added with the load address, actual load address, how many bits should be done like that. Yeah, this method is efficient. Modification bit method is efficient if at all we are using or we are writing an SIC XE program. But think of a situation where majority of operands need to be modified. How? When this situation will arise, we should pay an attention. For example, we don't have an SIC XE program, but instead we have an SIC program. If you remember, the SIC program allows you to use only 2 types of addressing modes. One is direct addressing mode. Second one is direct with indexed addressing modes, or I can call it as indexed addressing. So we are using direct addressing mode and indexed addressing. If the program, SIC program, is assembled relatively, that means it is assembled starting from the address 0000, then all the instructions apart from the assembler directives and the declarative statements need to be modified, because the operands of the SIC program either will have a direct addressing or either will have an indexed addressing. So every operand that is appearing beside your mnemonic in the program needs to be modified. Let me say if your program is having some 50 instructions, every instruction need to be modified, right? Okay, yeah. So this is a tedious task. So if 50 instructions, I need to have 50 modifications. If 100 instructions, I need to have 100 modifications, which is not a suitable solution what we can make it out. So suppose the situation is this: we have an SIC-XE program and majority of the instructions need to be modified. So what we do is, instead of using modification records, we use something called as bit mask, where not as an additional thing, but the bit mask in the text record itself, because after assembling, the object code will be written into the object code file format, which is containing header record and text record and end record. So in the text record itself, we're going to specify an reallocation bit mask, right? And this bit mask specifies which of these text records which is written need to be modified according to the load address. So an easy and a simple solution. We can understand that. Proceeding further, yeah. Let me think. One word in your text record is an entire text record is containing 12 words. Means 12 object codes you have written. 12 words means 12 into 24 bits, and each instruction in your SIC is 24 bits. So 12 words we have. 12 instructions is been written in your, what do you call, single text record. And the bit mask, which is usually the first word of your text record, will specify the bit mask. Something like here, the bit mask is given as FFC. Means first F is 15, that is 4 consecutive ones. Next is again an F, so another 4 consecutive ones. And the next one is a C. So we are getting 1100. By this, what we can understand means to say the first 8 plus 2, 10 bits need to be reallocated, means need to be added with the load address. Means in a bit mask, if with the bit mask is 1, it indicates that it needs modification, and if the bit mask is 0, it indicates there is no need of modification. Either it may be an assembler directive or a declarative statement, whatever it may be. So for that reason, we don't need to have modification record. Fine. So this is what is the indication. So one record or 124 bits or one word is kept aside, which is going to be acting as a bit mask. And this bit mask tells that how many text records need to be modified according to the start address of the program. This happens, please remember, I am repeating, this happens if you are writing an SIC program where majority of your, means where all the instructions are either direct addressing or indirect addressing. Then, and if your SIC program is assembled using the relative address, so majority of the instructions need to be modified. So modification record method is not suitable for this. So for that reason, we use a separate bit mask. If the bit mask indicates the bit is 1, it needs modification. If the bit is 0, it doesn't need any modification. So how many text records are there? Combining all of them, we will be taking one bit mask, which is going to be specified which of the text records need to be modified. So in our example, the 10 consecutive records need to be modified, and the last 2 records no need to be modified. Yeah, you can see the example which is as given in your textbook. So you can see there FFC, indicating first 10 bits need to be modified. Next one is E00, means E whatever you are going to get, that is 1110, means to say first 3 records need to be modified. Rest of them no need modification. So this is how the 2 different way of specifying reallocation can be done. One by using the modification records, which is suitable with SIC-XE programs, and the one by using reallocation bit mask, which is suitable for SIC program, which is assembled in a relative fashion. Fine. So these are the two variants of specifying the reallocation, machine dependent loader features. The next concept is a program linking. So from now onwards, the majority of the part will going to be looking at the linking aspect. So you should please visit back to that section of the class where we done the control section. So as a preamble, I'm going to tell you that control section is physically partitioning your program. Means you write the program in different files and they are assembled together so as to become a single program. This can be done in many programming languages. For example, in C also, we can write the functions of the same program in different source files and they can be compiled together. And we can also have an external variable which can be used as a common global variable between the programs written in multiple source files. So that need to be linked together. So how this happens, there are variety of techniques we're going to see. So we're going to refresh all our programming and compiling skills what we have learned earlier. So while looking at this program linking. Fine. Yeah, if the program is made up of control section, more than one control sections, then though they are assembled together, yes, of course, we're going to assemble all of them together. The linker will treat them as a separate control section. Each source program written in each different file is taken as a separate control section. Yeah, please don't get confused with the program blocks and control section. Program blocks is logical partitioning of the program within the same source file, wherein while assembling your past one, we're going to arrange the code belonging to each of the program block in a consecutive locations. And it will going to be assembled in a normal fashion. It is a single source file. But the control section, the source program is written in multiple source files and they will be treated as a separate source files or separate control sections, though they are assembled together. Fine. And this will be the case. Okay. And after this, to be added with the start address, means the starting address will be given relative to each one. Yeah, rather than talking about it, we shall see a program. This can give us a better understanding. Is a same program, whatever is used in the textbook, but if there is small variation, means with this a bit amount of simplification, so that it will going to be easy for us. Yeah, we have three such programs. One I am calling it as program A, program B, program C. Is the separate programs, small separate control sections written in three different files. Program A is a separate file, B is a separate file, C is a separate file. But we do have the external definitions and the external references between these three programs. That's what is the catch here. And how the linker works about it, it's what is the concept we're going to learn in program linking. Once we have understood this particular concept, the other variants of this can easily be understood. Yeah, have a look at the program. The name of the program is program A and it is start, and so we are telling to be assembled with starting from address 0000. Fine. We have some of the symbols which is defined here, may be used in the other control sections. Two such symbols are there. One is, so they are defined as EXTDEF, list A, comma, end A. These are defined here, used somewhere else. The next one is those symbols which are defined somewhere else, but may be used in this control section. Them we are calling it as EXTREF. We have four such symbols, list B, end B, list C, end C. So these are the four symbols defined somewhere else. So precisely B telling that list B and end B is defined in program B, list C and end C is written in program C. And the program is just to demonstrate the working of linker. So for that reason, we don't have the specific code for it. We have the references is the major concept. So at the location 0020, that is your location code, value 0020, we have a symbol called REF1. symbol means it's a label, ref1, and the instruction is LDA list A. So this don't need any external reference to be resolved because list A will be defined somewhere below. So this belongs to the same program. But you just see the ref2 label having a format 4 instruction plus LDT. It is telling list B plus 4. Means list B is not a symbol of this particular control section, but it will be the symbol of the other control section. That value need to be added with 4. So I got, you can see in the opcode place, list plus LDT value we have got, and followed by 0004. Means there is a 4 to be added. Is there with whom? With the value of list B. But this needs a modification record to be written by your assembler. So whenever it gets a value list B, that should be added with this 0004, and whatever the resultant will going to be the operand for this LDT. It may be an absolute address or it may be a relative address, whatever it may be, that will be the value for your operand value for your LDT. Similarly, I have ref3, which is also a label, which is having the instruction LDX, which is telling hash NDA, that is address of your NDA, minus list A, that is address of your list A. So NDA and list A both are STDF, means defined in the same control section. So we don't need a modification. So among this ref1, ref2, ref3, these three means labels. First one needs list A, third one needs the NDA minus list A. So we don't need a modification records. We need a modification record only for the instruction at 0023, that is list B plus 4, because list B is not defined in this control section, but is defined in some other control section. And see further at 0040 we have list A's definition, which is equal to star means current value of location counter, which we have seen already during expressions. And then after some time at 0054 we have NDA, which is equal to star again. So it is going to be having the value 0054. And list A's address will going to be 0040 and NDA address will going to be 0054. And I have one more variable, which is a declaration. Ref4 is the name of the variable, which is telling NDA minus list A plus list C. So as to resolve NDA minus list A, I don't need any external references or I don't need any modification record, because NDA is also defined in this control section only and list A is also defined in this control section. If I look at it 0054 minus 0040, obviously I'll go to get 0014. But this should be added with the address of list C, which we haven't got it, which we're going to get only after the link. So that's the reason in the opcode we have written only 0014. But this needs a modification record. So for this control section, 2 modification records is needed, one for list B, one for list C. Making you clear? So 2 modifications records is needed. So we get a modification records only when we have a external references, and this has to be resolved by your program link or during link. So list B is external reference, list C is external reference. These 2 need to be resolved. So we're going to add up a modification record for this. Fine. The same program or say similar sort of program we have in program B also. Yeah, you can see here. The next control section is called as program B, and external definition is it is supposed to be list B and list C. So once again, you can change. This is supposed to be, yeah, this should be B here. This should be B. Here this should be C, and this also should be C. Yeah, and the same sort of change I need to make in here. This should be C. This should be C. This should be B, and this should be B. Fine. Okay. Yeah. Now see the program B. Name of the program is program B, and external definition says list B and end B, which are defined in this control section. Similarly, external reference is list A and end A, which are defined in program A, and list C and end C, which will be defined in program C. And ref1 is a format 4 instruction, NEA, list A. This needs a modification record because list A is being defined in list A has been defined in program. Similarly, LDT list B plus 4. This doesn't need a modification record. So we got the complete implementation because list B is defined in this control section. You actually speaking about, you don't need this part of code part of it. Just you need to know which one needs a modification record or which one doesn't need a modification. Yeah, while writing in the exam also, you can write it in the similar fashion. Fine. And the next instruction, ref3, label ref3, is having hash NDA minus list A. We need 2 modification records for this. And from that modification records, whatever the result we're going to get, that is going to be our program, means our, what do you call, operand address. NDA is external reference defined in program A, and list A is also an external reference defined in program A. So similarly here, yeah, list B definition is appearing at 0030, which is equal to star, means the current address, that is 0030. And end B is appearing at 0070. So its address is 0070. So if I do list end B minus list B, I'm going to get 0040. But we don't have that sort of instruction. At 0070, we have a declaration which is label name is ref4, which is telling NDA, which needs a modification record, list A, which needs a modification record, list C, which needs a modification record. So if we look at it, the first instruction is having an operand list A, which needs a modification record. The second instruction is, that means the ref2 is having list B plus 4, which doesn't need a modification record because it is defined in current control section. The third instruction at 0020 is having 2 operands, NDA minus list A. Both are external reference, so we need 2 modification records. The last instruction at 0070 is having NDA minus list A plus list C. So we need 3 modification records. 3 plus 2 is 5, 5 plus 1 is 6 modification records is needed for the program B. But when we have seen the program A, we needed what? Somewhere around 2 modification records. Because there we had only 2 external references. Here we have some 2, 3 plus 4, 5, 6 external references. Proceeding further, we have the next thing, the program C. The program C has list C and end C is external definition, means external definition. List A, NDA, and list B, NB are external references. A similar sort of way. The first instruction is referring list A, I need 1 modification record. The second instruction is referring list B, I need 1 modification record. Ref3 is referring NDA and list A, I need 2 modification records. Similarly, I have list C and end C is defined at 0060 and 0070. At 0070, we have ref4, which is having list A minus, NDA minus list A plus list C. I don't need modification record for list C, but I need 2 modification records for NDA and list A, right? So NDA and list A is already been asked, so I don't need to add up another extra modification record. So we need 1, 2, 3, 4 modification records. The highest number of modification records are consumed by your program B. So 3 control sections, one is program A, program B, program C. This I have explained you as an example. You don't need to remember it as it is, but if you are able to make out how many modification records is needed, then does. So the same thing is been explained here. So which one needs how many modification records, which are those expressions which needs the external references in program A, and similarly in program B, and similarly in program C is being explain. Fine. Now let's go to the concept of our program linking. Program linking will be done in two passes. Pass 1, assign the addresses to all external symbols. Then pass 2 performs the actual loading and reallocation and linking. Fine. Pass 1 assigns addresses to all the external symbols means we're going to assign the relative address for each control section separately, because every control section is assembled starting from the address 0000. So, and all the instructions as well as the declarations will be assigned the addresses starting from 0000. Okay, everyone will going to get the address, relative address. So during the load, we get the load address, and that load address need to be added for all the control section address or the relative addresses given for your control sections. And then those operands means this will be assigned to all the symbols that is appearing towards the left hand side. But all those things that is appearing towards the right hand side, which are operands, need to be modified according to the load address of your control section. That will be called as reallocation, which will be done using your modification method. And wherever those addresses are used, one is used in the other. For example, list A is used in program B or program C. There, the same address need to be specified. That is what we call it as linking. This reallocation, linking, and then putting it onto the memory. These three tasks is done by your pass 2, but assigning the address will be done by your pass 1 of your linker. So how exactly these linkers work, we're going to see. But before that, we just see the data structure. This is very similar to your 2-pass assembly. Here also we are using 2-pass, but not for assembling, but for program linking, loading, reallocation. Fine? Yeah. So we use a table called as an external symbol table. Now it is not just a symbol table only for one program, but it's an external symbol table. This spans around all the control sections belonging to the same program, means all the source code written in multiple files. So it's the external symbol table, one symbol table for all the symbols from all your control sections, right? All those things that is having the heading as ext or ref in any of the files will going to be entered into this particular table with its address whenever it is resolved, right? Such sort of table we call it as what? External symbol table. Use it to store the name and address of the external symbols. One symbol may be an internal symbol for a particular control section, which may be used in other control section will become an external symbol. So a single entry for each symbol will happen. Okay, the table specify which control section they belong to. Yes, of course. Second one we have is a program address, which we call it as program address. Beginning address of the memory where the program is loaded. Who will going to give? Your operating system will going to give this particular address. When you put the program for execution, we first request the operating system to give an address where the program needs to be loaded. That address that is given by your operating system, we are calling it as a program address, which is also called as your load address, whatever you want, you can think it as. And this program address for the entire program, which may contain multiple control sections, right? And where each control section is loaded, that is going to be a separate address, which we call it as CS address. Yeah, which we are call it as CS address, control section address, the starting address assigned to that particular control section. Usually, the first control section and the program address will be same because it will be the loaded in starting from the beginning address of your load address. But that may not be the same for the next control section. It will going to be the next address after the first control section for the next consecutive control sections. Fine. Okay, the value is added to all relative address in the control section to get the actual address. Fine. So these are the controls. Means these are the data structures that is used in our program linking. Next, we shall see the algorithm for pass 1 and pass 2, how your program linking will happen. Remember, the program linking is doing too many tasks at the same time. What it is doing? First, it is assigning the addresses for all your control section and all the symbols. Second thing, it will make the entry into your external symbol table. It is going to get the address, load address from the operating system, and it is going to load the program and do the reallocation referring to your external symbol table, and it is going to load the perform the reallocation relative to the starting address. That's what I mean by the control section address, because all control sections will not be loaded starting from the load address. It is going to be loaded after the first control section where it is going to be placed. So it is performing the task of loading, 1. It is performing the task of reallocation, 2. It is performing the task of linking. Linking means modifying the operands which are external references. So 3 tasks will be done. So this happens just immediately after your assembly. So your assembler will consume some time for assembling. After this, linking, reallocation, loading will consume some time. And remember, this need to be repeated for every execution of your program. This need to be repeated for every execution of your program. Amount of time spent for assembling is a different task, and time spent for linking, loading, reallocation is a separate task. So this is a tedious task, including assembling these 3 steps for doing it. But we shall see the basic version, and then we'll go into the variations on this. We shall stop here. Next class we'll go into discuss about the pass 1 and the pass 2 in detail of your what you call program linking. Then we proceed. As I mentioned, your loaders and linkers has having much of the concepts rather than whatever we call it as problem or solving or numerical. Okay. Yeah. Thank you.